Hi, everyone. So I'll give people one more moment to come sit down. So yeah, I've been working on the Selenium project most of my career for my own sins. And I kind of learned a lot of things along the way. And today I want to kind of show you one of the kind of sometimes painful points that we have when people are trying to do automation. Because when WebDriver was created, the main understanding was that we would try emulate as best we could what a user would do or see. And so today, this is kind of where the basis of this talk came from. So a long time ago, in a galaxy not so far away, WebDriver was created about 10 years ago. And the internet 10 years ago was a lot simpler. Like HTML was a lot easier to use. CSS was also very restrictive. People designed nice-looking web pages using tables just so they could get everything to flow nicely. And it worked. Like, you could do things. And when WebDriver was trying to click on things, it was fairly obvious. You just kind of click on a link or click on a button, submit a form. It would work. You would type into things. And when you wanted to see if something was displayed or not displayed, the reasons why it would not be displayed were actually really small. So it was a lot simpler, and you could just work with it, and it was great. But to really understand, like, if something is really visible on a page, we kind of need to take a step back, have a basic understanding of how browsers render a web page, what it takes, like all the steps it goes through, before we can even handle going into Selenium and then trying to guess if that element is visible or not visible. So, how do browsers render web pages? The easy answer is magic. But we all know as computers, there's no magic. There's a lot of bugs, but there's no magic. So how do they go about doing this? So when we decide that we need to render a web page, like we decide we want to go visit something as simple as like google.com or bing.com. You type in the URL, you click a link, and this sets in motion a number of processes that the browser starts doing. It checks that the URL is valid, it then sends off for information, and then it starts downloading the web page. And when it's downloading the web page, it starts parsing all the HTML. And this is a very, very intricate process that it does this, because most web pages have invalid HTML, so it's not something you could just go, oh, we'll just use regex, it'll work. It never works. So it needs to parse all this information and kind of make sense of it so that we could use it later on. And when it's finished, like when it's parsing it, it starts building a DOM tree. Now, for those who don't know, the DOM is a tree-like representation of a web page. In WebDriver terms, if you want to find something within the DOM, it's driver.findElement, and we go searching the DOM for it. We ask the browser to go searching for it because they're a lot quicker than us, and they optimize it heavily because we're not the only use case. And so it goes down really, really nicely, and we get all this information. Cool, we have a DOM. So if I take this like basic HTML, like super, super basic. Oh, wrong way. this is kind of what the tree-like representation of a DOM looks like. Fairly simple. You have your document, which is what we describe as the web page. You have your root element, which is normally your HTML element, and everything then starts hanging off that. So like there's an element for head, an element for title, and within that there's a text node. So everything is just like nodes in a tree. Cool. But we're not finished. Like, this is just the HTML. Like, we've got no information about what actually needs to be rendered. Like, we have a structure of what things should do, but we have no way of actually like saying, render this element for us, please. And if we go back to like the HTML parsing, once it hits certain aspects that it goes, right, I actually need to go download something else. So like CSS, like that's a very important step. It needs to go find that information. It then disappears. Downloads all that information. And so it's got your video, it's got your images, it's got your CSS, like everything that can influence anything that can render. It's got all this information. It starts parsing it. It starts parsing all this information. And when it's parsing the CSS, does anyone want to guess what type structure it tries to produce? I can tell you it's not a tree, because everything else seems to be a tree within a browser. It's not a tree. It creates multiple lists that we can start using. And it's got all this information. It's got these CSS lists. It's got the DOM. And the browser says to itself, right, we're ready. We need to tell the operating system what to display, and we need to give it to the browser in a special format. And this special format is called the display list. The display list is kind of, it's described like in a way that, like from CSS specifications, like you will do the following, and you can generate it like this. All the CSS and all those lists from CSS and images and things like that are then applied to the DOM, and it does tree traversals. So the first traversal it'll do is called a pre-ordering traversal, which means like from the top to the bottom, and it'll apply certain styles. Once it gets to the bottom, it then works its way back up with other different styles. And it can do it up to 5 times, applying different aspects of the display list, which is like really important so that we can kind of understand what is going. And this is just a text representation of a display list. This is kind of what is sent over from a browser to the operating system and said, render this. And that is kind of how your browser like your web page gets rendered. Like on the face of it, it's kind of simple. It's back to this magic, you know. We've created this thing. However, browsers don't do certain things that when it comes to test automation would make our lives incredibly easy. When it's doing these traversals, these top-down and top-to-bottom and bottom-to-top traversals, it creates the list. It never optimizes the list to see if something should be rendered or should not be rendered. Because at this point, like, people feel that operating systems are so fast. Sometimes the operating system will offload something to the GPU. GPUs are a lot faster than CPUs. It just goes, handle it. And browsers will send over these things, and overpainting will happen, or overdrawing. And now overdrawing is like if you've got multiple elements, say this big, like I have a div this big, and another div this big, and another div this big. and they're all in the same place, we tell the operating system, paint all three for us, please. But this is what we think is probably going to be the top one, unless something else comes in its way. And that's what it does. Sorry, I'm just going to get a quick drink. So, ta-da! We have a web page. Really cool, really simple. And now we're ready for automation. So, what does Selenium do? The Selenium committers and numerous Googlers, Mozillians, and every other company who's submitted patches have essentially taken what they know browsers are doing when generating display lists, and all its nuances that go along the way, and try to reverse engineer it. So whenever you, as an engineer, go, element is displayed, it kicks into action a number of tasks that it starts doing. So if it looks at what element that you're wanting to kind of test, what element that you want to see if it's displayed or not, and goes, right, I'm at the bottom. I need every parent node, every element that becomes a parent to the element that you want, all the way to the top of the document. I need to know what all those elements are. It gets all those elements, and then it starts to loop through them. And it goes, are you actually visible? And it applies some basic heuristics and goes, is this element have a display of none? Is this display hidden? Is there a hidden attribute onto it? Is there a visibility changes to it? And we also check, really basically, if it has an opacity 0. Because it might be there, but you can't actually see it. And that's you want to be able to test if something is displayed. So if I wanted to check that the link, the bottom yellow one, was visible, I would need to get that one, the body, and the HTML, because CSS can be applied to anything at any point. And there could be inline styles, and we need to kind of check all of this. And when it's doing it, we're doing CSS calculations, we do, because the isDisplayed code within the Selenium project is written in JavaScript in what we call atoms, because they're kind of the smallest functions that we can kind of share out to all the different drivers. So we kind of query the browser through JavaScript, can we see this, can we not see this? And this should be easy, right? Super simple. It's either there, visible, or it's not. So, when we first created this, it was done. We knew these heuristics. We were good. The internet was going through, standards were slowing down because, Microsoft had kind of thought they'd won the war, and other browsers were trying to build up, and they weren't getting the amounts of people that they wanted. But for CSS 2.1, for the most part, we had solved most of the cases. Unfortunately, the CSS Working Group didn't stop working. They kind of thought, I know, mobile is the future. JavaScript is rubbish between browsers. If you've ever had to do cross-browser JavaScript, you kind of just want to pull your hair out, or kind of your hair goes gray. You drink heavily at 9 o'clock in the morning, things like that. Like these are the things that web developers have been doing for a very long time. So it was hard. And it's edge cases. Like, it's all bloody edge cases that come up. Daniel Wagner-Hall is a Selenium committer. Used to work for Simon as an intern. And he, as his intern project, he started creating Chrome driver. Like, he can do this. And one day, poor Daniel got so frustrated, he slammed his hands on the desk and said, edge cases. It's all bloody edge cases, and then stormed off. Simon had broken it. Poor Daniel, as an intern. His work year was done. But this is kind of the things that start to happen. CSS has moved on. They've created new, awesome features that people really, really like. But the good thing about web developers is they tend to be slow on the uptake of new features, mostly because not every browser has them. Like, it's hard to support multiple browsers, and if you work in design agencies, it needs to be pixel perfect between different browsers for some weird and crazy idea. But unless you're another type of company who tries to do things brand new and out there, Mozilla tried to be one of those companies, and they created Firefox OS. And they were trying to be revolutionary, not revolutionary, try to create a new idea that, we don't need apps, we've got the web would work, and we've got all these new cool features that are on the web platform. So they created Firefox OS, and that's kind of where the edge cases, at least for me, and it's displayed, started coming out. So one day, one of our engineers said, I've got this music app on Firefox OS. It's saying this element is displayed, but it literally cannot be displayed. Like, you cannot see it. And I went, why? He's like, well, because we've transformed it. So I was like, well, okay, I need to go now learn something new about CSS. What is CSS transforms? So find out. And what they'd done is they'd transformed it way off the page, and there's no way that we could ever scroll to it. So like, whenever we're trying to do displayed heuristics, we're like, would we be able to scroll to this element? Like, because we want to try to do display checks without actually scrolling, because otherwise your page would be going like that, and that's not nice. So we tried to do this, and he's like, there's no way you can scroll to it. Which then created an issue. So this is kind of a 3D visualization of the DOM that we had at the time, so I could kind of see where things were. But yeah, it wasn't fun. But we managed to solve it. So who wants to kind of see another issue? This one's still kind of live. It's something that it's a bit harder to test without kind of doing all the scrolling and really nasty stuff. If I have this element, it's just a span, it's green. Sorry for those who are colorblind. I do apologize. I was trying to get a color that would stand out. If I create another span, I haven't changed the color. I've just created another span, and I put it over it. So the HTML just looks like that. If I were to ask Selenium, is this element actually visible? It would go, yes, the green one is visible, and the red one. Because we can't actually see, from a coding point of view, where things are stacked on top of each other, because the display list doesn't always give this information. Browsers do not give this information away. It's kind of their secret sauce. They want things to be as quickly as possible. So I'm going to kind of try to show you some examples that I created. So I do apologize if you cannot see. Sorry, I cannot find my mouse. So yeah, for example, this is what I'm after. So here we have it's probably just going to flash up and flash down. Oh, still using the old one. Or did I actually? Right. Oh, it did flash up. So what this was doing was the span. Oh, I'm on the wrong. Oh, too many windows. Sorry, I do apologize. I'm trying to. So this is taking the span and just shows it. Some of the drivers are slightly cleverer than the others. So if I were to run this in Chrome driver throws an error going, it is visible, but you can't click it because something else is going to get it. So it has some basic heuristics there. The other example that I had was with transforms. Again, hopefully this is not going to be too quick. Oh, sorry. When you do tests, do things. So this is doing another transform. If I look over here, there is a transform, and it's hidden because it's kind of I've sent it off the page. And finally, here, this is a good example where actually we were able to change the heuristics. Like we said, oh, this is fine. This is not visible anymore. The final example I have is an interesting web application. I asked a few people in the Selenium IRC channel for their favorite issues, and then I picked from it. This is where I hope the internet still works. So this is a e-reader type application. Sometimes examples. Sorry, I'm just going to move this off the way so we can. Is this the right way? This is the right way. Try again. Hopefully it works this time. Oh. Sorry. I have too many browsers. So no, I'll go. Sorry, my demo's gone horribly wrong. Oh, well. Anyway, what this example was showing was as you click through the web pages, it generates iframes. So this one's actually a really interesting case. It would generate iframes in different places. And then you try to do visibilities on these weird and wonderful iframes, and they don't always show up because kind of sometimes you can't see through elements. You can't see through iframes for security reasons and things like that. And this was a wonderful case that I'd never seen before. Like someone only showed it to me yesterday. I will try to get this working if anyone wants to come find me later, and I'll try to show you that. But I do apologize. And multiple screens are not working in my favor. Aha, there we are. So what does this mean for the WebDriver specification? This is a really interesting case. Like, as much as I've kind of said, like, there's issues with this displayed, I see great value in is displayed. But when it comes to the specification, it creates an interesting thing. Because anything that kind of is described in the specification needs to go kind of through a few different questions. So like, we need to figure out what does Selenium do. The next step is we need to make sure that each of the drivers actually does that. A lot of the time there is a disconnect unless it's something that uses an atom and we can kind of push it on the drivers. But if something has to use like the language that the driver is built in, so for Internet Explorer, a lot of that is done in C++ with the atoms. For Firefox, it's all in JavaScript. For Chrome, it's kind of C and the atoms. And so they have each of their own kind of quirks, but they might not have reverse engineered everything perfectly. So we need to kind of go, yes, do all the drivers do this properly? And do we still want this, or could we improve it? And finally, and this is the most important part, like, has anyone else specified this? Because when it comes to like WebDriver is a unique case when it comes to specifications in that it's taking a whole bunch of specifications to give you an out-of-process API. Like it's the first of its kind of going through browsers and the W3C. And well, like Simon and I and the rest of the working group are pretty good at what we do. We don't really want to be we don't want to be specifying how browsers are supposed to be rendering because it's kind of hard. It would take a lot of work to kind of understand what they're doing in the first place. And then you also need to get a lot of buy-in from browser vendors that this is actually what they want to do. Like, they want to be able to give you this information. So currently, it's as an appendix to the specification because we want it there, but we don't know how to specify it. And we'll hopefully be able to solve this problem one day. So kind of the end of my talk is really like, when you're using isDisplayed, please still use it. Like, don't be afraid to not use it, but just be aware of its limitations. Like, and if you hit those limitations, raise a bug with the Selenium project. Like, help us fix these problems, because a lot of the times we're kind of fighting against how other browser vendors are doing things. There's new features coming up. They do different things, and they might be changed. The way it works in mobile might be different, and we need to handle all these cases. So kind of help us get it working as well as reasonably possible relative to life, happiness, and human morality is kind of the way we want it. And that is it from me. Thank you.